Welcome Geometry students to Triangle Congruence in section 4.2. We're going to be learning what SSS and SAS are. We're moving on to Thanksgiving, so hopefully you guys enjoy this themed notes. So let's start off by side, SSS, okay? Obviously the SSS stands for side. So the three letters, the letters in these types of triangle congruence problems are going to represent either S, which is equal to side, or they're going to say A, which is equal to angle, okay? There's one more, that's hypotenuse leg, but we're going to get to that in a little bit. So side theorem, what does that mean? Postulate, sorry. What does that mean? It means that we're going to have three sides congruent to each other. That means AB is be congruent to what? It's going to be congruent to DF. We're going to have BC, and that's going to be congruent to DE. And then we're going to have AC, and that is going to be congruent to FE. Okay, so if we have all three of those sides congruent, what does that mean? Well, in the previous section, we talked about how if we have all sides and all angles congruent, so if this angle is congruent, this angle, and this angle, and this angle, and this angle, so we have all angles and all sides congruent, then we know that the triangle is congruent. But is that the minimum amount of information we need to know? Do we have to really find every single angle and every single side? And the answer is no. For this particular case, we just need to find that all the sides are going to be congruent, and then the triangles will also be congruent. So I'm going to go over here to this color. So we're going to say triangle ABC will be congruent to triangle DEF. Wait, let's make sure I go in the same order. This is important. So A, I start here, going to blue. So I need to start from here, to go to the blue. Okay, so I have to actually change my order. It's not DEF. I have to make sure I write it in the same order with the same angles and sides. So this is FDE. Okay, because remember, FD and AB are congruent. So there's AB and there's FD. We need to make sure they're in the same spot written there too, okay? So caught myself on a mistake, make sure you guys do the same, but ABC is congruent to FDE. Now, we don't have to find the angles because if they have the same side lengths, there's no other way you can orient that triangle to have different angles. For example, let's say we have an equilateral triangle, 10, 10, 10, all right? We know that an equilateral triangle has angle measures of 60 degrees for the angles. Is there a way that we can have another triangle with 10, 10, 10, another equilateral triangle, and have the angles not equal 60 degrees? There is no possible way. If it's an equilateral triangle, it has three congruent angles, all of 60 degrees. So there's no other way. Side means all the angles are also going to be congruent. So here's our first example. Is KIT congruent to TEK? So we have KIT here, this triangle. Okay, just want to make sure I always identify the triangle that we're talking about, and then we have KT or TEK right there. Okay, so those are the triangles in question. One of the things you'll notice is that we have 70, 70, 70, 70, but then we have this missing value here. It's not important. The important thing is that they share it. And if it's shared, that means that's the reflexive property. The reflexive property states that a side is equal to itself. Well, the reason why we have to state the reflexive property is because that side belongs to two different triangles. So we have to say that it's congruent to each other because it's already congruent to itself. A little bit confusing, but the more you see exposure to this problem, you're going to get it a little bit more. So KIT, we have that the three sides are congruent. If we were to reorient these triangles, which I always recommend doing, okay, that would be the T here. If I flip this over like this would be the T, that would still be the E, and then the K is over here on the right. So we have TEK, is it congruent to KIT? And the answer is yes, because of SSS. Okay, now, is KIT congruent to EKT? So EKT would be starting at this top angle here and then working my way around the triangle this way, and it's not. Because we know that it's not going in the same order. So we know that this angle is congruent to this angle. We know that this angle is congruent to this angle, and we know that this angle is congruent to this angle. So we're starting from different angles that we don't know are congruent or not congruent, so we can't say no, we can't say that they're congruent. Now, SAS, what do you think that means? Well, hopefully you remember that S stands for side, A stands for angle, and then side again. So this is the side angle side postulate. This is very important. Side angle side happens in order, okay? One after the other. And that's true for all these congruent triangles theorems and postulates, that these are one after the other. So it's this side, the very next side, the very next side. This is a side, the very next angle, and then the very next side. It's always in order of the next available thing, okay? You can't go like, well, I'll demonstrate in just a second. So first, let's get our congruent lines set up here. We have AB congruent to FD. We have angle A congruent to, where would this be? Between the purple and the red, so that's there, angle F. And then we have AC's got to be congruent to FE. Okay. Now, so once we have that established, then we can say that triangle, and we got to go in order here. This time I'm just going to start at the blue angle, and I'm going to work my way this way. It's very important that you kind of do this self-selection for yourself. ACB is going to be congruent to F triangle FED. Okay, so that's a little ugly. All right, FED. As we can see here, we had the purple side, okay, AC in the same spot as we had FE. That's a way to check to see if you did that correctly. All right, now let's be clear on something. This is a side, okay, if we're labeling this, we can call this a side. Now, we could, once we're labeling it, we have to look for the given angle. So we see that the given angle is right here, and then we see it also right here on this triangle. So as we're going around, we want to go that way from the given side towards that angle. So we see that the angle is the very next thing. There's an angle, A for angle. Then we go around again, and we see that the very next side, if we're doing side angle side, is here. So it has to be sandwiched in between. Side angle side, that angle needs to be sandwiched directly in the middle between those two sides. So we have, what I'm trying to say is it can't be something like this. Side, we skip this angle and we go to this angle, and then we say this is our other side. It can't be that situation. The two sides need to be sandwiched directly in between those angles. So we have side, angle, this is our given angle, and then side. A lot of students mess up with the labeling here, and I'm going to get into it once we get into more problems. But yeah, I just wanted to make sure we clear that up. It's the next available. So we have two things going on here. We got congruent sides in this problem, and we're trying to see if we got congruent triangles. But we can already tell that we have vertical angles. Sometimes it's not going to be given. You'll have to determine that. So this case, we had to determine, okay, these angles are vertical, so they're also going to be congruent. So what do we got going on? Let's analyze. Well, right here we have a given side, okay? And we're going to go to the next given thing. Well, there's no givens up here, okay? Notice how we skip an angle and we skip a side. If we skip two things like that, then we're not going in the correct direction, okay? So we notice that we should be going, okay, let's go in this direction towards the given angle, because the given angle is right here. And we see how we have a given angle on the other one also. So then we keep going. Let me label here. So that was a side. Then we had a given angle. And then we have, what do you know? A side. So this is side, angle, side, because they're all directly next to each other. That's an angle sandwiched between two sides. Now, is it the same down here? Well, they always need to match. So this side needs to match that side. This side needs to match that side. Done. This angle needs to match that angle. Done. It matches because it's vertical. And then this side needs to match this side. It does because it's given as congruent. They're both 4. So we have side angle side between these two triangles. Now we just need to see if they're labeled correctly. So what I like to do is I like to flip it. So I have this purple triangle here. I flip it and I get, this is going to be A over here now. Then we have B to the left and we have C on top. And then this triangle, this green, we'll call this the red triangle. The red triangle, we have D, C on top, and E on the right. So is B, C, E Okay, BC, there is no E. Where's the E? Oh, BCE is all the way down here. BCE, that's not even a triangle, so this is no. Okay, BCE and DCE. So that's no because why is there an E there? This is not congruent. What about ABC and CED? So ABC starts at this right side, keeping in mind that we know that these angles are equal, right? And then this is the left one, because I reoriented it, and then we have the top one, and then here's the top one. That's actually the green one. Okay, so we're going from A, B, C, so we're going clockwise here. Is it congruent to C, E, D? Notice how I started different spots. I started at the bottom right angle for this one, and for the red one, I started at the top angle, C. So these are also not congruent. So what would be congruent would be triangle ABC. It'd be congruent to triangle EDC because we're going in the same direction and we're starting from the same angles, hitting up the same congruent sides, etc. Okay? We're going to do more practice with this, so stay tuned and make sure to join us next time on Wes Explains Best. Almost lost it there. All right, bye.